Hello everyone, my name is Aditya, and this talk is titled Koro, Translating Code to Other Human Languages and Back Again. I've been writing Go full-time for over 8 years now, and a lot has changed in that time. This right here is from the source code of the Go 1.0 compiler back in 2012. If you don't write C, there's a lot of unfamiliar stuff there. You might be able to get a sense of what's happening, but not completely, and it would be much harder to write it yourself than to read it. This was a huge barrier to contributing to the Go project, and everyone recognized it. Think about it. We're here to contribute to the Go project. We already know how to use Go, so why should we need to learn different language, C, just to do that? So we rewrote the entire Go compiler from C to Go, and that was released in 2015. We did that largely with the C to Go translator that translated the code automatically, and the remainder was done by hand, little fine-tuning fixes here and there. There's a great talk from the very first GopherCon about how we did this. But that only removes one language barrier, and there's still one more to contributing to Go. Go development happens almost entirely in English. That's true both of the official Go project and also of popular projects that use Go, like Docker and Kubernetes, Prometheus, Hugo, many more. A person's ability to contribute to those projects is going to be greatly limited if they don't have at least a working grasp of English. Even reading the code, understanding what things like function, if, case, fall through, all those mean. That's something that you and I might take for granted, but for some people, even reading the Latin script is an extra barrier. And this is not just a barrier for a small number of people. In fact, it's a barrier for the majority of the world. Less than 5% of the world speaks English as their first language. Over 95% of the world does not speak English as their first language. And in fact, over 80% of the world doesn't speak English at all. We can look at this visually too. That oval shape that you see right there is actually a circle. The map projection makes it look warped, but on a globe it would be perfectly circular. More people live inside that circle than outside of it. That circle represents over half of the world's population. So that's important for us to think about when we think about what technology is. Technology, including software, is a powerful enabling force. We have the ability with software to do truly amazing things on a global scale. Thanks to software, we were able to take last year the photo, first time ever, of a black hole 55 million light years away. Thanks to software, we've been able to treat and cure diseases that even just decades ago would have been fatal. We don't always think of those as achievements of software, but they really are. Without the software that underpins them, that was used to actually execute them, we would never have been able to accomplish them. But software can also be used for some pretty horrible purposes as well. People have written software that's been used to enable oppression, to inflict violence, or even to commit crimes against humanity. The single largest genocide of the 20th century was committed with the help of a Silicon Valley giant that created specialized software to track people as they were sent to extermination camps. At the end of the day, software is a tool, and as a tool, its purpose is determined by the people who build it and wield it. If we think that software is a powerful and enabling force, then we need to look with a critical lens at who it enables. If software is only an option for the 5 to 20% of the people who speak English, whether as a first or a second language, then that has huge implications about what kind of software is going to get built and what that software is going to be used to do. So if we believe that software is a great enabler, then writing software needs to be an option for the entire world, not just those 5 to 20% who happen to speak English. And if Go wants to be the future of software development, writing Go needs to be accessible to people who speak all languages as well, not just English. The idea of eliminating natural language barriers to programming is not new at all. In fact, it's very old. Grace Hopper is one of the first computer scientists, and she wrote the first compiler for a programming language. The language that she invented was called COBOL, and the goal was to have English-like natural language syntax so that business executives could write code. And she received a lot of pushback about this. Engineers were furious. They thought, well, if non-engineers could write code, this could put us out of a job. But Hopper's vision took this even further. Why restrict this to English-like syntax? What if engineers who spoke other languages wanted to write programs as well? She wanted COBOL to be, and I quote, a language you can use to talk to programmers around the world. The response to that was even more vitriolic. He said, well, how can we teach American computers to run German programs? And to be clear, this is not a question of how it could be done technically. This was a decade and a half after World War II, so the thought of a threat from Germany or Russia was still a very big fear in people's minds. But even if Hopper's idea was put on the back burner due to xenophobia and politics in the 1950s, we can look at what it means today and learn from that approach. This is Hopper speaking about COBOL many years later. She said, I would have thought that it would be useful to NATO because they already had the common verbs for the things that they were going to do. And the nouns, they just have to have a dictionary for the things that they were referring to for inventory control. They'd have common nouns throughout NATO, and they could make a dictionary of common verbs and translate the program. You could write one in English, and you could translate it, and it could go to the other language. No problem. You'd have communication. It would be a limited vocabulary. Now, it's interesting to note that Hopper chose the imperative mood, the commanding form of verbs, specifically because she believed that that would be universal to all languages. Not all languages distinguish between past and present and future tenses, but languages generally have a way of commanding people to do something. And COBOL was one of the languages which popularized imperative programming styles, so it stuck with us to this day. You'll notice how, even in Go, function names are usually imperative. That's indirectly a result of this tradition. So let's see what we get when we take those same principles behind Hopper's vision and apply them to a modern programming language like Go. So to answer this question, we can look at Koro. Koro is a project that's an extension of the Go compiler and toolchain to support Bengali. The name Koro is an idiomatic translation of the English name Go. And a special thanks to Alice Kelly for drawing the logo here, which is a Bengal tiger, in the style of the Go gopher. Now there are two language decisions that this project makes. There's the decision to use Go and the decision to use Bengali. We'll get to why I chose Go in a moment, but as for Bengali, well, it's the language my family speaks, and if you talk to any Bengali person, you'll find that we tend to be very proud of our language. But it's also a practical language for this choice as well. After Hindi, it's the most common language spoken in India, and it's also the national language of Bangladesh, which combined makes it the 5th most widely spoken language in the entire world. It's more common than Portuguese, Russian, Japanese, French, or German. It's a more widely spoken first language than German and French combined. And importantly, it's also a language that uses a non-Latin script. If we can prove that we are able to translate Go to languages not just that have Latin scripts like French and German, but to languages that have other scripts, that opens up the possibilities for translating Go and making it accessible to people who speak a whole wide range of languages all over the world. But of course, nothing that I'm going to show you here is unique to Bengali. So if you speak another language, I'd encourage you to try it out yourselves. So let's take a look at how this works in practice. This is a familiar Hello World program that's written in Go. It does nothing but prints Hello World and exits. And this is that same equivalent program written in Koro. Now, we've left the identifier names intact, but the keywords are all now in Bengali. And no, true is, we didn't forget about that. That's actually not a keyword in Go. People are sometimes surprised when they see the slide to learn that. True is not a keyword. It's defined within the compiler and runtime, but it's not actually a keyword. So the first challenge that we have with this is that we need to get the program to run. The standard Go compiler isn't going to know what to do with these keywords if we just feed it to them. And so to understand how we get it to run, let's take a look at how a compiler is actually built. A compiler at its core is just a program that takes an input string, a sequence of bytes, and translates that to a different sequence of bytes, an output string. That input string is the program, and the output is usually a machine executable binary. So it has a few different stages it uses. The first one is called the Lexer. And the Lexer will take the input string and chop it up into different tokens. It's like identifying the words or identifying the parts of speech within a piece of text. But it doesn't actually figure out what the semantic meaning of those is. So that's what the parser is for. And the parser we'll figure out, okay, we've got the adjective here, the noun here, verb here, like this is how those all fit together and what meaning we generate from that. And that meaning gets expressed as an abstract syntax tree. That's the internal representation of the program. Then that gets passed on to later stages of the compiler, which then will do other things and optimize it and then generate the output. But those first two stages, the Lexer and the parser, are what are called the front end of the compiler. And that's what we're concerned with today. You can see here just a visual representation of what a Lexer is and what it does. So on the top, you have that input, and it reads one byte at a time, but it has to know which bytes, are grouped together. And so it will color those, and it'll color the keyword if. It'll figure out, okay, this is the keyword if, so I need to replace that with this particular known entity. But then it'll read things like a numeric literal, and it'll then have to group those together. Or it might look at the addition assignment operator right there, which is a plus sign and an equal sign. And an addition assignment operator, we know, is related to addition and it's related to assignment, but it's not literally the same thing as having an addition operator followed by an assignment operator. No, that combined has a separate semantic meaning. So the Lexer needs to be able to look at that and say, okay, this particular pair of characters has a completely different meaning, and it needs to know what to map that to in the internal representation of a single token. But it still isn't concerned with what that actually means. It just is concerned with what that is. It doesn't think about what's on the left side, what's on the right side, what is it adding, what is it assigning. That's all done by the parser. Now, Go's source code is all UTF-8, so the compiler has no trouble dealing with non-ASCII characters in Go programs. And the Go compiler itself is written in Go, so the Go compiler is just a Go program. And that means that the Go compiler has no trouble dealing with non-ASCII keyword definitions. Now, there are a few internal checks that will ensure that non-Latin and non-alphabetic characters are excluded from keywords, but it turns out that you can just disable those without any issue. So all we have to do is extend the Lexer to handle the Bengali translations of each keyword. So in the compiler, the Go compiler, you'll find this map which has a series of English keywords, and it maps those to, map of string to int32, so like some internal representation of what what that keyword, of how that keyword is going to be stored. And we just have to extend that to understand Bengali versions of a keyword. And this is all done purely by the Lexer. The parser has no idea that anything has changed. In fact, the part that the parser sees is exactly the same. This is not something that you can do with this method easily, like in most other languages, the way you can in Go, because those languages use C-based Lexers, like Flex, and that doesn't support multi-byte code points. So you can't just feed it a UTF-8 character and expect that the Lexer is going to be able to handle it. So there's a reason that I'm giving this talk at a Go conference, not at a Python conference. I love Go and I've been writing it for over 8 years, but more than that, this is just literally not something that you can do in Python, at least nowhere near as easily. You'd have to start digging into the Lexer not just the Lexer, you have to start digging into the parser and messing around with what the semantic meaning of these combinations of tokens actually would end up being. And even in the original Go compiler written in C, that used Flex, so it would have been much messier. You'd need to actually start digging around with a much more sensitive part of the compiler that has more just delicate and complicated operations. So having made those changes, here's that Hello World program in practice. You can see here that we have the program in Bengali, and we run it through koro, which then executes it the same way it would if it were a Go program in English, and we get the Hello World. But remember, our goal is to defragment, or is to grow and to unify the open source world, not to fragment it any further. So we want to make sure that our code is interoperable with code that's written by English-speaking Go developers. And we don't want to have to translate every program manually. Well, as for the translation, Go already has a handy utility for formatting source code called GoFormat. And mostly we use that to prevent bike shedding over things like the tabs versus spaces arguments. So instead of arguing over the proper way to format source code, everyone can just set up their editor the way that they want. And so if I want to use 4 spaces for indentation and you want to use 2 spaces, GoFormat means that we can still work together. We just each set up our editors to render tabs at the width that we want. And after we save our code, we run GoFormat and it'll automatically translate our code to the standard style. No work needed. And in fact, we don't even need to be aware that we have different indentation preferences because the code that gets committed is in the standard form and our editors will display it in our preferred forms. But GoFormat can handle a lot more as well, like it can remove unnecessary parentheses from expressions if you ask it to. And it's syntax aware, so it's smart enough that it will never change code semantics, which is a simple way of saying that it's a good tool for performing fully isomorphic translations of Go source code. So with that, we can extend it to perform a translation from Bengali source code to English Go source code. And that's exactly what koro format does. So let's translate koro back into English Go. We start off with the Bengali Go program, and then we run it through koro format, and we get an English Go program. But we can also prove here that it actually has the same semantic meaning. We write that to another file and run that through the standard English Go compiler, and we get the same result. So the same way that you didn't know that I was using 4 spaces for tabs and I didn't know that you were using 2, having bidirectional translation layers means that you don't need to know that I'm writing my code in English. And I don't need to know that you're writing your code in Bengali or in Spanish or in Arabic or any other language. We can localize our source code as a commit hook. And as a developer, koro means that you only ever need to be able to look at source code in your own language. So as far as the code is concerned, our language preferences are no more of a barrier between you and me than our indentation preferences are. And that's the way that it should be. All right, so we've translated the keywords, but you'll notice that we didn't touch everything. Like we didn't get the package name or the variable names. There's been a lot that's written about the topic of choosing good variable names. And the one thing that everyone seems to agree on is that they should be both descriptive and concise. So, of course, if we leave the names in English, as most open source projects do, that's not going to be very descriptive to someone who doesn't speak English. So we want to think, is there a way that we can translate these as well? Well, fortunately, in reality, there are many variable and function names are already highly structured. As Hopper mentioned, we already have the verbs that we use quite frequently when writing code. Like read, write, close, those appear all over not just the standard library, but also third-party code as well. And they're used in slightly different contexts, but they have the same core meaning, just applied in slightly different ways. So we can take advantage of that knowledge and translate those in the translation step as well. And GoFormat already gives us the same building blocks to make renaming transformations like these. We normally use it to rename variables from this one language to that same language, but we can easily repurpose it to rename a variable from one language to another. So by being a little bit more conscious about the conventions we're already using, we can make our code much more accessible to non-English speakers. As you can see here, we might not know what foo is, but we do know that we can automatically translate read to poro, write to likho, and so forth. And we might not get all the translations for free, but we still get a lot of them. And that's a huge help for someone who doesn't read English and is like, well, I don't know what foo means here, but I do know that this method reads something with regards to foo, or this method writes something with regards to foo. And that makes that piece of code much more accessible to someone, even without having to speak English. They can fill in the blanks themselves. Now, in programming software for reliability and high availability, handling failure modes is just as important as handling the successful operations. In fact, maybe even more so. And so it's critical that we give developers who are using our code insight into the error outcomes, regardless of what language that they happen to speak, if we want that code to be used around the world. Now, Go has an approach to error handling that is different from most other languages. In Go, an error is simply any value that happens to have an error method on it, where that error method returns a string. That's it. That string value is the only thing that you're guaranteed to be able to access about an error. And because it's the only guarantee, it's critical to make that accessible and intelligible to people in whatever language they happen to understand. Because as developers, we've all struggled with cryptic error messages. This one right here is one of my favorites from Java. Cannot cast parameter type system.string to argument type system.string. And I love this example because, even as someone who speaks English as their first language or as a first language and someone who knows a little bit of Java, you still can't really look at that and unless you're very intimately familiar with Java error messages, understand what it's trying to say. Like those individual words make sense and you can kind of get how they're supposed to fit together, but it still doesn't really tell you what you need to do to fix it. And Go isn't immune to this either. I'm using Java as an easy example for since we're not primarily Java programmers, but every language has their own examples like these of cryptic error messages. But the only thing that's worse than a cryptic error message is a cryptic error message in a language that you can't even understand. So error messages are a great starting point because not only are they going to be finite in number, but translating them will have a huge impact on your collaborators as well. And they're the easiest to solve from a technical perspective because we can use existing localization strategies. Many languages already have libraries that assist with this, that they'll provide variants of specific textual strings depending on the designated locale. They'll do things like assist with pluralization. So if you want to say error could not read file versus could not read files, some languages will change the word files to pluralize it, some won't, and it'll help you with the concordance there. And Go already has internationalization libraries, which we use for things like, web programming or other consumer-facing stuff, but we should use those for our developer tools as well. But of course, our goal is to be able to do all this automatically. Translating error messages by hand might be fine, but documentation is going to get a little bit trickier. And so I'm sure I'm not the only one here who's used Google Translate to, translate a text and found some amusing places where it stumbles over idioms or words that have multiple meanings. But tools like Google Translate can actually work quite well for technical documentation. And there's a reason for that. Because we're not looking to translate all English to another language and back again. We're only looking at translating our open source software, both the code and the documentation. And as it turns out, automatic translation works particularly well for specialized technical texts and texts that have very narrow contexts. This is similar to the way that we have the C2Go translation tool. It was written for the specific form of C that was written in the Go compiler. It's not meant for all C code. In fact, you can't use it to translate all C to Go, but you can use it for that narrow context of C that we knew that we were limiting ourselves to when writing the Go compiler. So here's an example of how that would work. On the left, you've got some documentation from the Go standard library, and on the right, we have that same documentation translated automatically into Bengali. But of course, if you don't read Bengali, this doesn't look very impressive. I could tell you that it's a pretty good translation and ask you to take my word for it, but that's going to be a bit anticlimactic. So let's see what happens if we try to translate that Bengali text back into English and use that as a proxy for how much information gets lost in each step. So we get some amusing errors here like code, but you do get the gist of what's going on reading this. You can understand what the general context of this documentation is. And I didn't edit this at all. The punctuation, the capitalization, everything is all exactly what Google Translate provided. Bengali doesn't even have capital letters, and they were still translated back correctly from context. This is, analogous to C2Go. We use that to get us 80 to 90% of the way there, and that was a starting point for the rest of the translation, the touch-ups that we did by hand. And this automatic translation can still be used in that same way to get the gist of it, and then you do the remaining bits, you fill in the blanks or do it by hand. So maybe you're still skeptical. So let's just, for fun, try translating the original text into Bengali, translating the Bengali text into Spanish, and then translating that Spanish text back into English. So this isn't great, but you still do get the gist of what's going on. Not as well as you did with the previous two, but you still get an idea. And even if it's not perfect, it's a whole lot better than no documentation at all, which is effectively what most open source projects have for languages that aren't English. For most open source projects, if you don't speak English, there's no documentation that's provided for you that you can actually readily access as part of the project. As for the presentation of this, we already have an existing model for how to present the same information in different languages, because Wikipedia does a good job of this. Wikipedia, you have the main page, but then you also have on the left a panel where you can see the different alternate translations of that same alternate language versions of that same page, where you can view them, but also crucially, you can edit them as well. And you can, if you speak those languages, you can then improve and update those other versions. And Wikipedia actually now has started to include a header. If you look at particularly like historical figures or political figures of a different country where most of the information is going to be in the language for that country, you'll see a header at the top which actually says, this information, this page is incomplete. You can try expanding it with information from one of the other translations. And the goal there is not obviously for automatic translation. It's for people who do speak that language natively, but might not know all the information to be able to write the Wikipedia page from scratch, that they can read that other page and then, translate it by hand and fill in the blanks. So you can still bridge that gap and make that information much more accessible to a larger number of people. So you might be thinking, well, if automatic translation works so well, why do I need to bother? Like, can't they just use a browser extension to translate and localize content automatically? And that's what people are already doing. And we saw the numbers. It's not working. The reason it's failing is not just because automatic translation isn't good enough. It's because relying on machine-generated translations makes for a very alienating experience. It doesn't make people feel welcome or encouraged to participate. In the past, when I've surveyed people about this, it's been a very common point. One of my coworkers actually said that when he was first learning to program from French websites, it took years before he felt comfortable participating in English-speaking ones. Because even though he spoke English, he didn't feel that the English forums were as welcoming to people who didn't have very good English skills. The goal with automatic translation here isn't to be perfect. It's to plant the seed. It's to signal that you're interested in making your project open and accessible to people who don't speak English, that you're willing to invite them in as part of your project. So now, once you've planted the seed, you may be surprised by how many native speakers of other languages are drawn to your project. But you don't have to wait. You can actively reach out within your project's community. You might not speak Spanish or Russian or Hindi, but there's a good chance that someone who already uses or works on your open source project does. If you go to almost any conference organized around a specific piece of open source software, you're basically guaranteed to hear a talk, or maybe multiple talks, on how to encourage more people to contribute to the project. And it turns out that asking for community translations is a great way of engaging and getting people over that initial hump of contributing for the first time. But the key is that you have to ask. And it might sound obvious now that I'm saying it, but it's not something that your users are going to think to do unless you make a clear point of doing it. And it doesn't have to be overly elaborate. Create the same way you do with any other issues, project milestones, file tickets, label them by language so people can filter and see what's needed and how they can contribute based on the knowledge that they have and also the time that they have available. But open source software is not just the code we write. It's also the community and the social networks that we construct around it. And we can localize the social networks that we build around code in two different ways. We can build events, bring events to the community, or we can bring the community to the events. And both are ultimately going to be necessary. Luckily, the Go community already does a mixture of both, but we could do more. Bringing the events to the community looks like, what we have here with, the conferences. In most years, we have, where GopherCon is not virtualized, we have one main large Go conference that happens in the US and in English, but we also have many other different local conferences as well. You have, and some of those have tracks that are in other languages. So like in GopherCon Brazil, there are talks in English and in Portuguese. In GopherCon Vietnam, there are talks in English and there are talks in Vietnamese. And of course, in China, most of the content's actually in Chinese, but there's some content in English. So that's what it looks like to bring events to the community. But we also want to unify our open source community, so we want to bring the community to events as well. And that looks like not just making it easier for people to travel to and provide opportunities for them to visit conferences that aren't just where they are, but also to access that content in a language that they can understand. So for conferences, things like having professional interpreters to include non-English speakers or non-native speakers is very helpful. Having interpreters who can have experience translating technical topics so that they can, get the jargon right, goes a long way towards making that content accessible. And even if you can't get a translator, having captions, the way a lot of conferences nowadays do, that helps not just people who are hard of hearing, but it also helps people who don't speak English as a first language. They can, read the text in addition to hearing it, or they can even translate it based on that written text, if it's recorded. Now, software development isn't just about writing the code. It's also about deciding what to write and how to write it. As a thought experiment for, I'd encourage you to think about what it would look like to encourage people in your own open source projects to write in the language that they feel most comfortable expressing themselves in, even if that language is not English. And if that makes you uncomfortable, I'd take a moment to examine why. Why does it make us uncomfortable for us as English speakers to think about experiencing the same barrier in project communication that most people in the world would have to experience today if they wanted to contribute to and participate in the projects that we work on? A lot of key project communication happens over mailing lists, and it's hard for developers to be truly first-class citizens in open source development if they can't participate in conversations around project direction or technical discussions. As we saw earlier, even non-native speakers don't always feel as welcome as participants in developer mailing lists, even if they do speak the language to a degree. So encourage people to participate in mailing lists by writing in the language that they feel most comfortable with, expressing their thoughts in. Just as with documentation and errors, there's a good chance that there are already others in your language community who could be willing to help bridge that gap and summarize or translate for them. It's also a great way to make non-native English speakers feel more comfortable using imperfect English on mailing lists as well. It establishes the project as thoroughly accessible to people of all linguistic backgrounds, and it'll assuage the fear that some non-native speakers may have when using what's, for them, going to be a second language. Now, there are a lot of different steps you could take to including non-English speakers more in software development, and making tools for translating code to other languages, like we saw here with Koro, is just one of them. If anyone's interested in going home and making something like what Koro does for Go and in Bengali work for another language that you happen to speak, like Spanish or German or French, I definitely encourage you to do that. It's a great way to learn about how compilers work in general, about string encoding, about Unicode, and it's a great way to learn about the internals of the Go compiler as well. And those are skills that you can use and pick up later on and develop for contributing in other ways to the upstream Go project in the future. But in addition to having these options for building technologies and tools to solve the problem, there are also straightforward and low-tech ways that we can make non-English speakers involve them more in Go development. And those involve like the ways that we operate as a community, the ways we decide to communicate with each other. We're really just scratching the surface here. But for any of that to work, we need to commit ourselves to doing it. We need to remember that 95% of the world speaks a language that's not English as their first language. And more than 80% of the world doesn't speak English at all. That's the vast majority of people who could be contributing to our projects today. But between native support for UTF-8 and an already very internationally diverse user base, there's no other language that's as well suited as Go is to being used by the entire world, not just those 5 to 20% who speak English. We have an opportunity with Go to bridge the language divide in a way that no other programming language has ever been able to do. So let's do it. Let's make Go the first programming language that's truly accessible to everyone, no matter what language you happen to speak. Thank you.